Okay, students, very good evening for you all again. So we are going to start the today's discussion under the data mining and predictive analysis course unit, right? So we are going to start the point where we have stopped last week, right? Uh, so we started the discussion under the dimension reduction. So today I can start from the making a recap for you. Then I have already uploaded the practicals document, right? So they are already, yeah, you can see the dimension reduction. This is the part actually we are going to discuss today. And you can use these codes to get in the outputs and all. Before before moving for this, you should need to understand what is dimension reduction and how to interpret these outcomes. Then what is the core behind this? Why we are going to do these kind of things and why we are doing these things? These are the areas first you need to understand. Otherwise, you are not able to explain these things, right? So you can create however using these codes. Yes, generally it works. Simply you can copy and paste where the R software. You can run it, but that is not the case. Actually, you should need to have the capability to explain those things. Otherwise, it will not make any sense. So that is why first we need to study about the theory, and then you can easily explain these outcomes, right? So that is the thing you should need to understand, right? So අපි පහුගිය කාල පරිච්ඡේදයේ කතා කරේත් එහෙම තමයි. අපි නිකන් ගිහිල්ලා ක්ලස්ටරින් ගැන මේ R software එක ඇතුලේ ක්ලස්ටරින් කරන්නේ කොහොමද කියලා පෙන්වන්නේ නෑ. ඒ ක්ලස්ටරින් කියන්නේ මොකද්ද? ක්ලස්ටරින් කරන එකේ වැදගත්කම මොකද්ද? ඒක මැනුවලි කරනවා නම් මෙහෙමයි, software එකකින් කරනවා නම් මෙන්න මෙහෙමයි කියන කාරණාව අපි ඉගෙනගෙන තිබුණා. So today actually we are going to discuss the dimension reduction, why we need to have this dimension reduction and all the things actually we want to discuss. Right. If we are coming to the session, actually I need to show you another one. So I have already uploaded the PDF document as well. This is for you. This is for you to study. So what the thing I am going to discuss today. So everything incorporated here. So please take some times to download this document and go through it. So there I clearly explain what is dimension reduction and why we are going to do these things and what the method we can use for that. Principal component analysis, that is the way actually we can do it, right? So then if you are coming to the session, yes, is there anyone, can you remember what do you mean by dimension reduction? එතකොට අපි ගිය සතියේ කතා කරා dimension reduction කියන්නේ මොකක්ද කියන කාරණාවල. හැබැයි අපිට dimension reduction කියන එකක් ඕන වෙන්නේ. මේ කාරණාවේදී yes, you can get the meaning by looking at the topic as well. Dimension reduction. Dimensional reduction. Yes, dimension means it is explaining some variables, right? It is explaining the variable. If you are talking about the table, in a table you have columns and rows. So the dimension interpreting, it's showing using columns actually, right? In your table, whatever the columns you are getting, yes, we can call it as a dimension. Your age, your address, or your weight, sometimes your mobile number. So everything we can call it as dimension. අපි සිංහලෙන් කියනවා මානයන් කියලා. Then the reduction means අඩු කිරීම. Then dimension reduction means you are going to deduct, you are going to eliminate the unnecessary dimension from your tables. For why? If I'm asking why, what the purpose? The reason is when you are going to create your algorithms, or if you are going to visualize these things, or if you are going to analyze these things, yes, the high level of dimensionalities may be a barrier for you. It will take more times to run the program. it will take the accuracy, basically accuracy will reduce based on this high dimensionality. So that is why we are going to reduce it. අපි table එකක් ඇතුලේ තියෙන dimensions ගන්න වැඩි වෙන්න ළමයි. If we are going to identify the patterns, if you are going to identify the patterns, how you are going to identify the patterns? Simply, yes, we are identifying the correlation in between two variables. Variables ගන්න වැඩි වෙන්න මොකද වෙන්නේ? අපිට මේක ඇතුලේ තියෙන correlation එක identify කරන්න ටිකක් අමාරු වෙනවා. සමහරවිට ඔයාලා මේ කියන මේ ඇල්ගොරිතම් එකක් එක්සිකියුට් කරන්න ගියොත් ඒ ඇල්ගොරිතම් එක ප්‍රොසීඩ් වෙන්න යන ටයිම් එක වැඩි වෙන්න පුළුවන්. සමහරවිට ඒකේ එන අවුට්පුට් එක ඇකියුරේට් නොවෙන්න පුළුවන්. So the reason is, yes, you are using high dimensionality data sets, right? So there what you need to do is actually, if you can reduce these dimensions, then it will make a big point. It will create a benefit for you to keep your accuracy of the algorithm sometimes. Then it will keep your accuracy of the insights, then time saving. So everything happen, right? So that is the basic understanding, right? That is the basic understanding of having this dimension reduction, right? Dimensional reduction. That is the main core behind this. Right. Up to now, is there an issue? So we discuss about yes, the dimension reduction first part. Yes. Now you know why we need to have the dimension reduction, right? So it improve your visualization basically. Then it reduce your noise in your data set. Noise it will reduce. Then it avoid the cause of dimensionality. Then enhance the performance of machine learning algorithm. So everything we discuss. Those are the key points you need to note down in your book. Then basically, very basically, actually, we are using two techniques. Actually, first one is we are calling feature selection. The second one is feature extraction. We'll discuss, right? No worries. I will show you one by one. Feature selection and feature extractions. They are the feature extraction under the technique of the feature extractions. So we used principal component analysis, right? Principal component analysis. So that is the thing actually you should need to understand. When it's come to the your part, that means practicals. Also, we are discussing about the PCA, principal component analysis. That is the thing you need to do in next week, right? So with that, we can come to the theoretical explanation with the drawings, right? So I will share my whiteboard. Could you please tell me, is it visible? Yes, tell me, is it visible? My Word document, can you see it? Yes, thank you very much. Okay, so now you can see it, right? Okay. Then I am explaining one by one, the point by point. Then if you want, you can get the notes there. So very basically what we need to discuss here, actually I can switch off my video, right? Then it's better. I can manage it. Okay. Then what we can understand under the dimension reduction, now you know we are going to reduce or we are going to eliminate the unnecessary dimension from your databases. For why? If I'm asking why, Kumak Sandhad. So the reason is, yes, you need to get the high performance machine learning algorithms, and you need to have the accurate visualization. So that is why you are going to eliminate the dimension that is not making any additional support for your insights. If I'm asking a simple question, students, there are a number of columns in your table. So assume you are going to make a decision relating to the healthcare. There are some information relating to your personal life. Sometimes your age, then your history, sometimes your names, sometimes your mobile number, email addresses. Then, other than these personal informations, so they are going to take the information relevant to your height, weight, then pressure, blood group, and sugar level. These are the things they are going to collect. All are dimensions. Your name is a dimension, your age is a dimension, your address is a dimension, then your blood group is dimension, your sugar level is a dimension. So everything's are dimensions. You can recognize those are the dimensions. Then I'm asking, if you are going to make a decision, or if you are going to identify an algorithm related to the healthcare. So is there any value addition, or is there any benefit by keeping these addresses or your names and your personal information? Actually, students, it will not make any sense. හිතන්න ළමයි ඔයාලා හෙල්ත් කෙයාර් එක සම්බන්ධයෙන් නැත්නම් අපි ඇල්ගොරිතම් එකක් හදන්නේ මේ එක එක පුද්ගලයාගේ data අරගෙන එතකොට අපිට තියෙනවා පුද්ගලයෙක්ගේ නම, ගම, වයස, address එක ඔය කියන කාරණාත් එක්ක එයාගේ blood group එක, එයාගේ උස, බර, sugar level එක මේ කියන කාරණාත් එක්ක මේ table එක තියෙනකොට if you are going to create a machine learning algorithm for getting some insights relevant to the healthcare, so are you going to think about, are you going to pay your attention for the patient name? Are you going to think about, or are you going to pay your attention for the patient address? It's not make any sense sometimes. Very basically, actually, you need to pay your attention on blood group, sugar level, sometimes height, sometimes weight. Yes, those are the dimensions. Actually, you need to use your decision. Clear? Is it clear? Yes or no? Yes, thank you so much. I have a message. Yes, that means ultimately what you need to do is you don't want to take all the dimensions for your decision making. You need to take the most important variables and the dimensions for your decision making things. So that is why we have the technique dimensional reduction. So that is the ultimate or the underlying objective of having this session. Okay, I think now you can have proper idea about this. I will take a small table. Could you please tell me if it is not visible, right? I am going to draw a table like this. Assume this is a table. It consists or it contained the weight of the student. This is a 2-column table. I am getting here it as a student number. Then another column I am taking it as a weight. These are the 2 columns actually, right? Then in this side or in vertically you can identify the columns and horizontally you can identify the rows. If assume there are 5 students, 1, 2, 3, and 4, and 5. There are 5 students there. Then I am going to take the weight according to the 5 students. Then student number 1, the weight would be 32.53. Then the student number 2, the weight would be 29.12. Then student number 3, weight would be 41.81. Student number 4, 37.69. Student number 5, 54.73. These are the respective weightages, or we can call it as weight. Then this is a simple table you can see. So this side actually we can call it as a sample. This side we can call it as a sample. Or you can say it as a what? Observations. Observations. Right? Then in this 2 columns, or these 2 columns, we can call it as features. We can call it as features. It is very similar for dimensions. The similar word for the dimension, features. So rows, actually rows showing the sample, and the columns showing the features. Features. If you have this kind of table, right? So we are getting the feature table as the weight. Why? Because of students number is not necessary. It is not make any insight. Here I will take the feature as the weight. There you have only 1 column and there are 1, 2, 3, 4, 5 observations. Here you have 5 observations in a 1 column. If you are taking this as a matrix, do you know what is matrix? Stat වලට ඉගෙන ගන්න ඇති matrix කියලා જાතිය. මොනවද ඒවට කියන්නේ? සිංහලෙන් කියන්නේ මොකද්ද matrix වලට? මොනවද ළමයි matrix වලට සිංහලෙන් කියන්නේ? Anyone? Is there anyone? කවුරු ඉන්නද matrix වලට සිංහලෙන් කියන්නේ මොකද්ද කියලාද? Hello. නැත්නම් ඔයාලට කියන්න ඕන. Is there anyone? No one. දෙයනේ ගණන් පන්ති කියලා නැද්ද? අහලා තියෙනවද න්‍යාස කියලා જાතිය? න්‍යාස. ඒවා O level කාලේ ඉගෙන ගත්තා මං හිතන්නේ න්‍යාස කියලා જાතිය. So if we take this as a न्यास, if we take this as a matrix, you can say it as like this. How? You have 5 variables, right? Sorry, 5 samples. You can take it as 5. What happened? You can have 5 as a sample, then you can multiply it by 1. 1 is the column. Number of samples are 5 and the column number is 1. This is, call it as 5 to 1 matrix. 5 to 1 matrix, right? The number 5 showing, right? Number 5 showing the sample, number 1 showing the feature, that means the number of dimension. Number of dimensions. Right? This is 5 to 1 matrix. Then, if you want to rename it, or if you need to identify this one, we are calling or we are identifying it by using the column number. So we can call it as what? This is a one-dimensional data matrix. So by looking at these two, yes, the one showing the dimension, number of dimensions showing number 1. So we are calling this as one-dimensional data matrix. How we can say it as one-dimensional data matrix. Right? One-dimensional data matrix. එතකොට one-dimensional data matrix එක කිව්වොත් එකපාරට ඔළුවට එන්න ඕනේ මේ table එක ඇතුලේ තියෙන එක feature එකයි කියලා. නැත්නම් එක dimension එකයි කියලා. Right? We discussed those things in last day as well, right? So we discussed those things. Again, then we need to understand one dimension, two dimension, and three dimension data, how we can show in a graph. That is the next thing we need to identify. How to show these dimensional things in a graph. If you are taking these three things like this, again, I need to have some tables, right? Assume first you have the one-dimensional data. One-dimensional data. How? This is the table. 1, 2, 3, and 4. Those are the observation. You have the x value, that is the feature value. You have 1, or we can take 4, 10, 40, 25, and 48. These are the observation. If I am asking, what is this matrix? How we can call it as? This kind of matrix, we are calling it as one-dimensional data matrix. Why? You have only one dimension here. You have only y. So you here you have only x here, right? Here you have only x here. So that is the only one dimension you can identify. That is why we are calling it as a 1D. 1D. One dimension. One dimension. One dimension data matrix. Then if I'm asked you to draw this in a graph, how you can draw? Yes, you can have the x-axis, or you can say, yes, this is one axis, there is another axis. Here, you need to get one axis as ID, or we can say it as here, yes, student ID. Here you can take it as X. ID means student number 1, student number 2, student number 3, student number 4. Yes, you can plot it 1 to 10, 2 to 40, 3 to 25, 4 to 48. Likewise, you can draw it. You can draw it. This is the way actually you can draw, and based on that you can identify, is there any correlations? Is there any correlation in between this? Right? So here actually you have only one. Here you have only one dimension. No worries. Actually using one variable, yes, you can make the decision easily. Why? Because of this, there is only one variable. Then, if we are going to talk about the two-dimensional data set, assume ID same like before, then you have two dimension, X and Y. Here you have the same information like previously, 10, 40, 25, and 48. Four. Then I'm taking some information, or I'm taking some data point for Y as well, 50 and 20, and again 60 and 65. These are the data point relevant to the Y. So this type of matrix or data set, how we can call it as, when it the dimensional perspective, how we can call it as? Yes, is it one dimension or two dimension or three dimension? We can call it as 1D, 2D, and 3D. Yes, this is. Yes, I have a message. It is a two-dimensional thing. Thank you so much. So number 06, your answer is very correct. This is a two-dimensional thing, right? So we can call it as what? Two-dimensional. Two-dimensional data matrix. So we can call it as 2D. 2D. Then if I'm asking to draw this, how you can draw? Yes, again, you are getting two axes. Like here, actually, you are not going to use the ID as axis. Here, you are going to take X and Y. X and Y. So here, the data points here, actually, in very first chart, your data points showing the values only for the how we can call it as. Actually, if you are taking one data point in showing the respective feature value for one particular student. It's showing the one respective feature value relevant to the one student. But when it's come to the second graph, that is 2D graph, here if I am taking a one point, here actually it's showing two figures. It's showing two figures or two features. And what particular point? It's showing two figures. That means if you are taking here, first observation, student number 1 or student 1, he obtained 10 and 50. 10 for X side, 50 for Y side. I think this would be the point actually we should need to identify. That means here you can identify 50, here you can identify 10. That means this data point actually interpreted the value for student number 1. Student number 1. Actually, here showing the student number 1 data point. If you are taking the second one, second student, yes, he obtained 44x, 44x, then 24y. Then this is the data point actually you can identify. This is the second student information. Likewise, you can draw the other lines as well, or the other point as well, right? Like, assume it will work like this. That means here you use two axes for the two features. Points showing the sample. Clear? අපි කලින් ප්‍රස්ථාරයේ 2D ප්‍රස්ථාරය ගත්තාම ආරණ දෙකක් ළමයි අපි එතන දකින්නේ. 1D graph එක ගත්තාම එක axis එකකින් feature එක පෙන්නනවා. මේ බලන්න axis x කිව්වහම ඒකෙන් පෙන්නන්නේ feature එක. හැබැයි අනිත් axis එකෙන් පෙන්නන්නේ ඔයාගේ sample එක. එහෙම නැත්නම් ඔයාගේ observation එක. student number 1 ගත්ත අපි හිතමු ඒක subject mark එකක් කියලා ලකුණු ප්‍රමාණය. student number 2 ගත්ත subject එකට ගත්ත ලකුණු ප්‍රමාණය. student number 3 subject එකට ගත්ත ලකුණු ප්‍රමාණය respectively පෙන්නනවා මෙන්න මේ කියන 1D graph එකේ. හැබැයි අපි 2D graph එකට යනවා. අපි 2D graph එකට ගියපුවම අපිට එක axis එකකින් විතරක් නෙමෙයි. axis දෙකෙන්ම අපිට පෙන්නන්නේ මොකද්ද feature එකක්. මේ axis එකෙන් x subject එකට ගත්ත ලකුණු ප්‍රමාණය. මේ axis එකෙන් y subject එකට ගත්ත ලකුණු ප්‍රමාණයක් පෙන්වනවා. ඒ කියන්නේ axis දෙකෙන්ම values දෙකක් පෙන්වනවා කියන එකයි අපි තේරුම් ගන්න ඕනේ. එතකොට මේකේ තියෙන එක data point එකකින් තමයි අපි ඇතුලේ පෙන්වන්නේ එහෙනම් අපේ sample එක. එක data point එකකින් නැත්නම් මෙතන තියෙන එක point එකකින් ඔයාලට තේරෙනවා dimensions දෙකක් ගැන කතා කරනවා කියලා. That is why we are calling it as a 2D dimension or the 2D. Previously we discussed about the 1D. Okay, then 2D අපි ඉගෙන ගත්තා. 1D ඉගෙන ගත්තා. Then if you want to show another dimension, assume this is the table actually you are having. Yes, you are having student, that means student ID. So number 1, 2, 3 and 4. Here you have subject X, subject Y, subject we can call it as Z. Now you have 3 subjects. The same information you can use (20, 60, 65). I will use another number set for the Z as well. Here 10, 12, 65 and 20. Now you can see how many dimensions are there. You have 3 dimensions: subject X, subject Y, subject Z. Now we can call it as 3D. If I am asking you to draw this in a graph, if I am asking you to draw this in a graph, how you are going to draw it? Yes, you know, simply, yes, you have 2 axes. This is one and this is another. That means easily you can show or the interpret 2 dimensions. Easily you can show 2 dimensions. If you want to show the another or the additional dimensions, what you can do? Yes, this is the way actually you can do it. So I will use another color for that. Otherwise it will not work. You can show the other dimension or the next dimension like this. Right, like a box, right? I can't draw it clearly, right? So this is like a box. Then if you are going to put a, if you are going to mark a point here, yes, it's showing, yes, there is a one axis, it's showing Y mark. There is another axis, it's showing X mark. Then there is another axis as well. What is that? So simply we are calling height, length, other one is width. උස දිග පළල කියන කාරණාවේදී ඔයාට මෙතනින් තවත් ඊතලයක් දාලා ඔයාට තව ඇක්සිස් එකක් පෙන්වන්න පුළුවන්, that is the z. Simply you can say it as yes දිග, or we can say it as like this, right? Simply yes, this is the length, this is the width. It's not working. This is the width and this is the height. Now you have 3 dimensions. Right? Here you have one axis, x. Here you have y. Here you have z. Length, width, and height. උස දිග පළල කියන කාරණා තුනම පෙන්වන්න පුළුවන් අවස්ථාවලදී අපි කියනවා 3D කියලා. Right? Okay. If you have 3 dimensions, that easily you can identify and you can draw it. But I am asking, if there is any other dimension, that means 4th dimension is going to be added to this table. What you can do? Could you please draw it? Yes, please, sir. Please take a paper and pen and try to draw a 4D graph. Please try. Please try with this. What is your idea? Is it able to do that? Is it able to do that? Anyone? Yes, sometimes you can, but easily you can't do it. Sometimes if you are trying with some software, yes, it will showing, but manually it is so hard to draw this. Clear? Is it clear? Okay. Then students, first we need to identify what are the dimensions. Then if you have the less number of dimensions, yes, it will make easier to make our decision. That is my next point. You can see 1D, 2D, and 3D. That is why we try out to eliminate the unnecessary dimensions from your data sets. Why? Because so then and only we can make our decision accurately. Then and only we can develop our models accurately, and model complexity will reduce. So 1D, 2D, 3D, that's better. If you are going to add more than 3, yes, it can be happen, but the thing is actually, yes, your accuracy of the model or sometimes the data analysis outcomes and the insights and your visualizations not make the expected outcome. So easily you can draw these 3 things, 1-dimensional things, 2-dimensional things, and 3-dimensional things. Then it showing the what the importance of having the dimensional reduction. Table එකේ dimensions 10ක් තිබ්බා කියලා අපේ තීරණයට මේ තීරණය ගන්නකොට dimensions 10ම ගන්න ඕන කියලා කාරණාවක් නැහැ. ඔයාලට තේරෙනවා මේ කියන කාරණාව මොකද්ද? ඒකයි අපි conclude කරේ මෙතෙන්ට. එහෙම නැත්නම් මම ඔයාලට කියනවා 4 වෙනි dimension එකක් ඇඳලා පෙන්නන්න පුතේ කියලා. So it is making somewhat difficult situation for us, right? It will make some difficulties for us. So your task is, as analyst, as visualization or the visualization or the visuals generators, or we can call it as, yes, program developers. So you should need to identify what would be the better feature for my decision. So how to identify it? That is the very basic thing. මේ කියන කිසිම කාරණාවක් නෙමෙයි අපිට වැදගත්. අපිට මේ කියන dimension එක අඳුරගන්නේ කොහොමද කියන එක. So I will show it. Actually, in a high level, actually we are going to study those things here. We are not going to do the calculations basically. You need to calculate the variances. You need to get the square root of this or the square values you need to take. So actually manually we are not going to do these things. Why? Because of we are having the tools, softwares and techniques. So simply you can upload the data to the systems. Easily you can generate whatever the insights, and your machine learning machine learning algorithms also going to be work with that. So for the time being, as a undergraduate, you should need to understand the theory behind this. That's enough. So we are not going to do the manual calculation. It will take much time and it is somewhat difficult to calculate. So easily we can use R software or whatever or the Python as well. Yes, for getting these things. Or if you want to reduce the dimensions, it's showing the approximate dimensions according to your view. 1, 2, or 3, whatever the components analysis. Or you can say, I need to have one principal component. I need to have two principal components. I need to have three principal components. Likewise, you can decide. Based on that, yes, output is coming. So that is the thing actually you should need to understand. Clear? I think it is clear. Then we will move to the next part of the today's discussion. Right. So we discussed, students, about the high dimensional data. What do you mean by high dimensional data? So you can identify number of features in your data set. Is it good or bad? Actually, data set එක ලොකු වෙන තරමට තමයි ළමයි ඔයාලට හොඳ. Why? data වැඩි කියලා කියන්නේ අපිට ඉන්සයිට් ජෙනරේට් කරන්න තියෙන ප්‍රමාණය වැඩි. හැබැයි අපි මෙතන කතා කරන්නේ මොකද්ද? data ඔයා හොයාගන්න ප්‍රමාණය අඩු කරන්න කියන එක නෙමෙයි. That is not the discussion we are taking here. What we are discussing here, when you are going to create the insight, අපි මේ කියන්නේ data එකතු කරන්න එපා කියන එක නෙමෙයි. ඔයාට පුළුවන් තරම් data එකතු කරන්න. That is the best way to make the decision. But how you can generate the insights? Actually, you should need to identify the most important features within your data set. Otherwise, you can't identify any patterns and the clusters, and you can't do anything. Right? So if I'm taking the very good example, the Netflix and YouTube recommendations and all, yes, first they need to identify the correlation in between your variables, right? So they are taking the most valuable dimensions, most valuable 2 or 3 dimensions to make their decisions. Not taking everything to the discussion point, or not taking everything to the insight creation. So that is why we discussing the dimension reduction here. So very basically, high dimensional data, right? It is making some disadvantages. It makes some disadvantages. Yes, could you please tell me one or two? I have already discussed. Yes, could you please tell me one or two? Yes, you can take down your notes, right? Actually, more features, actually more dimensions, more features direct into the high dimensional data. High dimensional data හැදෙන්නෙම feature ගාන වැඩි වෙන්න තමයි. ඒක ඔයාලා දන්න obvious. Then I'm asking, what is the problem? අපිට ඉතින් data ගාන වැඩි වෙන එක ප්‍රශ්නයක්ද? That is my question. That type of questions can be tested in your exam paper as well. Yes, I'm asking small question. More features or more dimensions directing to creating a high dimensional data. It's okay. No issue. Obviously, you need to accept it. What is the problem? What is the issue with the high dimensional data? That is my problem. That is the thing you need to explain. That is the thing you need to elaborate. Wedding dimension we discussed this. Yes or no? Definitely. Then, if you have this high dimensional data, what happened to you? What happened to your data set? Actually, data visualization and difficulties can be arise. Data visualizational problems can be arise. So difficulties can be arise. Next thing is when you are going to do the data analytics part. So there are insights also not generating as you expected way. The level would be differ than what you have expected. When you are going to understand the data, very basically, when you are going to understand the data, yes, it also make difficulties. Then your time is going to be waste, right? So time wasting process. Then when it's come to the model development, it also make a confusions. Right? We can call it as a yes, you may be confused with the model development. It will not be work or it will not perform well. So due to this high dimensional data. So there is the point, or that is the point. You should need to use your technical knowledge or the theoretical knowledge. There you should need to reduce the dimensions or the features in your data set. Why? We discuss. Those are the bad points or disadvantages you are having with the high dimensional data. I think it is clear. Then, when it's come to the dimensional reduction, right? What you are going to do is first you need to identify what are the unnecessary dimensions, unnecessary features for your decision. That is the first thing you need to understand. Otherwise, තමන්ගේ කාරණාවට අදාළම කරන ඩයිමෙන්ෂන් එකක් අයින් කරලා දාන්න පුළුවන්. හිතන්න ඔයා ඉන්සයිට් එකක් ජෙනරේට් කරන්න හදන්නේ නැත්නම් මැෂින් ලර්නින් ඇල්ගොරිතම් එකක් ඩෙවලොප් කරන්න හදන්නේ මොඩල් එකක් ඩෙවලොප් කරන්න හදන්නේ මේ මොඩල් එකට අවශ්‍යම කරන ෆීචර් එක අතහැරලා අනිත් සේරම ටික ගනි. සමහරවිට අපේ ස්ටුඩන්ට්ස්ලා රිසර්ච් කරන්නේත් එහෙම තමයි. They are bringing some topics, right? They are bringing some topics to the board, to the table. If I'm asking what is the independent variable and the dependent variable, they are saying the number of variables, number of dependent and independent variables. But by looking at the literatures, by looking at the past findings, they missed the most important independent variable. They missed it out, the most important independent variable. That means they look and they identify the most of the independent variables that or those variables are not make any result for your ultimate finding, right? So that is why here also we are saying if you want to get some outcome effectively without having any difficulties, just you need to identify the what is the most important fact or the figure or the feature for your decision making. By looking at this, you can keep it, others you can eliminate. Keep it, others you can eliminate. So that we can call it as a dimensional reduction. Dimensional reduction means you are going to reduce the multiple variables that are not make any contribution for your decision making. Or unrelevant features you are going to eliminate. So that is a simple understanding. I think it is also clear. Now we are going to study what are the ways actually we are having. That is the most important thing. What are the ways actually having to do this? What is the thing? Actually, you are going to do the eliminate the unnecessary features. අපිට හිතෙන එක අංක ගණන් කරලා 7 වෙනියට තියෙන ෆීචර් එක අයින් කරනවා. දෙවෙනියට තියෙන ෆීචර් එක අපි අයින් කරනවා. එහෙම නැත්නම් පළවෙනි ෆීචර් එක අපි අයින් කරනවා. 9 හොඳ නෑ 9 වෙනි ෆීචර් එක අයින් කරනවා. කියලා අපිට ෆීචර්ස් අයින් කරන්න බෑ. For the dimensions we can't do it. Actually you should need to have a rationale, or you can use some statistical tools or techniques to do this. Basically we have two things. Basically we are having two ways to do this dimension reduction. First one is feature selection. We discussed, right? Feature selection. What do you mean by feature selection? Feature selection means, the very good example is, I explain you. Assume you are going to develop a model for the health system, a healthcare system. So now you have a number of columns, number of rows. There you have a number of features and the samples. Then based on the table, you decide. You have the experience. Assume you are a doctor. You can get the consultancy facilities from the doctors. As a analyst, you can get the consultancy facilities or consultancy service from the doctors. Based on your table, you can show it to the consultancy board, and you can get the approval, and you can get the feedbacks and the comment from them. What are the unnecessary features according to their understanding? Then you can get the ideas, and you can eliminate, or you can reduce, or you can keep it away what the dimensions, what the features recommended by the doctors. That is, we are calling feature selection. Feature selection somewhat depends on your idea, your perspectives, and your experience. It will depend. අපි තමයි තීරණය කරන්නේ. මෙහෙම ටේබල් එක දීලා තියෙනකොට columns ගන්න දීලා තියෙනකොට then we think this would make some more insights for my decision, right? Then I need to take the most important variables, or I need to keep these two for my model development. Exactly. If we are taking one example, yes, here is the table, right? This is the table. Assume you are going to develop a model for healthcare, system. Then you are having number of variables. You can say patient ID, name, address, age, gender, weight. By looking at this, assume this database, or this data set, or this table having high dimensional data. That is the issue. High dimensional data. This is the high dimensional data set. If I am giving the chance you to eliminate, some features, what are the features actually you are going to eliminate by looking at this? If I am going to develop or deploy the model for the healthcare system, what are the features actually you are going to eliminate? අපි මේ healthcare system මෙහෙම නම් මේ ලෙඩේ හැදෙනවා, මේ වයසේදී මේ ලෙඩේ හැදෙනවා, මොකක් හරි අපි ඇල්ගොරිතම් එකක් හදන්න හදනවා කියලා හිතමුකෝ. මේ වයසේදී මේ කියන ජෙන්ඩර් එකට මේ බර තියෙනවා නම් මේ ලෙඩේ හැදෙනවා වගේ පොඩි මේ ඇල්ගොරිතම් එකක් හදා ගන්නයි හදන්නේ, මොඩල් එකක් හදන්නයි හදන්නේ. මේ වයසේදී නම් මේ බර තිබුණොත් වැඩේ පොඩ්ඩක් අවුල්. Likewise, then you can develop that kind of equation for your examination. That means in your research as well, right? අපේ රිසර්ච් කරන ළමයිට මම මේ කියන්නේ AIS එකේ ස්ටුඩන්ට්ස් ලා කවුරු හරි ඉන්නවනම් හැම වෙලේම ERP සිස්ටම් එකක් උස්සගෙන ඉන්න එපා. කාට හරි පුළුවන් නම් ප්‍රැක්ටිකල් ඩේටා සෙට් එකක් හොයාගෙන ඉවරලා model එකක් develop කරන්න. Machine learning algorithm එකක් develop කරන්න. Yes, you can collect more and more information. Based on that, you are going to conclude මේ වයසේ ඉන්න මේ කට්ටියට මේ ගති ලක්ෂණේ තියෙනවා නම් එයාට මේ ලෙඩේ තියෙනවා කියලා හොයන්න පුළුවන් නම් ඔයාට අපි දානවා regression outcome එකක්. very simply ඒක එහෙම කරන්න බෑ. කියන්නේ මේ මම දැන් උගන්නන විදියට කරන්න බෑ. assume අපි දාගන්නවා variables පහක් තියෙනවා right x1 x2 x3 then you have final answer for this. I am taking it as y. So plus minus beta 0. So this is your final model. අපිට මේ x1 වලින් කියන්නේ age එක. x2 වලින් කියලා කියන්නේ weight එක. x3 වලින් කියලා කියන්නේ gender එක. By getting this answer, මේක analyze කරලානේ කරන්නේ ළමයි. මේක number of data අරගෙන ගොඩක් අයගේ ලක්ෂණ දිහා බලලා අපි බලනවා cluster කරලා data mining techniques ටික දාලා අපි regression outcome එකක් අරගෙන data plots ටික අරගෙන බලනවා මෙන්න මේ අපි හිතමුකෝ ඔයාට මේකෙන් එන්නේ value එක 30 කියලා yes ඔයා බලනවා ඔයාගේ outcome එකේ ඔයා හදා ගන්න මෙන්න මේ විදිහේ table එකක් 10ත් 30ත් අතර answer එකක් එනවනම් he has issue with their pressure. pressure එකේ පොඩි ප්‍රශ්නයක් තියෙනවා. 30ත් 40ත් අතර උත්තරයක් එනවා නම් අනිවාර්යයෙන්ම මෙයාගේ heart ප්‍රශ්නයක් තියෙනවා. 40ත් 60ත් අතර නම් මෙයාගේ තියෙන්නේ sugar level එකේ අවුල් එකක්. නැත්නම් sugar වල අවුල් එකක්. Likewise, you may have different type of answers. Based on that, you are concluding. This is the actual model for the Sri Lanka. If anyone can test this, then you can identify your illnesses. That is very good. That is the innovation you need to do. That ERP system implementation, cloud computing. So please don't bring those type of things to the research. It's okay. That is the academic research. I can accept it. But as a technological peoples, yes, you can do rather than that. You can generate or you can identify the models for the society, model for the nation. If it is work, ඒක හරියට වැඩ කරොත් මම දන්නේ ඒක කරන්න පුළුවන් නම් හොඳයි. හරියට වැඩ කරොත් ළමයි මේක ඔයාලට විකුණනවා සල්ලි හම්බ කරනවා. So that is why we are saying model development. Please take this kind of things to the your research. Why you are not bringing these things to your research? Actually, why? That is my question. මේ වගේ එකක් කරන්න පුළුවන් නම් කොච්චර හොඳයිද? ඇල්ගොරිතම් එක රන් කරලා බලනවා වැඩේ සෙට් වෙනවද කියලා. අන්තිමේට කන්ක්ලූඩ් කරනවා මං හොයාගත්ත ලංකාවට මොඩල් එකක්. මේ මොඩල් එකෙන් කියවෙනවා ලංකාවේ මිනිසුන්ට තියෙන ලෙඩ ගැන. ඒක සඳහා මම එකතු කරන්නේ මිනිසුන්ගේ වයස, බර සහ ස්ත්‍රී පුරුෂභාවය කියන වගේ කරුණු කීපයක් විතරයි. ඒකෙන් මම ජෙනරේට් කරන මොඩල් එකෙන් මට කියන්න පුළුවන් මෙයාට මේ වෙද්දි තියෙන්නේ මොන විදිහේ සංකූලතාවද කියලා. So that's good. That's good. That's the best way. That's the best way to do that. Okay. Then I'm asking. Then my question. By looking at this table, what are the figures actually you are going to select? What are the points actually you are going to select? Yes, very basically, you can take the age, you can take the gender, and you can take the weight. These are the three things actually I can take into my account when I am going to develop my model. So that kind of decision, that kind of practices we are calling feature selection. Selection done by myself. Feature selection. That is the one way you can use to dimensional reduction. I think it is clear. Yes or no? Yes or no? Okay. Good. Then are cloud computing, ERP systems, accounting information system, fintech. හොයාගත්ත ළමයි තමන්ගේ මාතෘකාව අයින් කරන්න කියලා නෙමෙයි මම මේ කියන්නේ. ටිකක් වෙනස් විදිහකට හිතන්න කියලා මම කියන්නේ. එතකොට අපි මේ ඩිග්‍රී ප්‍රෝග්‍රෑම් එක ඇතුලේ අපි රිසර්ච් කරනවා නම් අපි මොන වගේ දේවල්ද කරන්න ඕනේ? So you are having number of data sets, right? You can develop some models, then you can recommend something. Okay, we'll see how to do that. Okay. Then we are coming to discuss the next part. That is the next way. That is we are calling feature extraction. Feature extraction. For that, actually, we are using principal component analysis. Principal component analysis we are using for doing the feature extraction. Right? That is the thing actually we are doing using the R software as well. There, what the thing you are doing? That is the thing you need to understand. අපි දැන් තමයි අපි තේරුම් ගන්න ඕනේ මොකක්ද අපි මේ කරන්න කියන කාරණාව. Assume you are having two-dimensional data set. Two-dimensional data set. Right? X and Y. X and Y. අපි feature එක තෝරගන්න හදන්නේ හොඳේ. එතකොට වාගේ තියෙනවා මෙතනින් student 1, student 2, student 3, student 4, student 5 කියලා. Then according to the X number of you have two subjects, then you have 40, 50, 70, 15 and 30. Then you are having 20, 30, 60, 20 and 40. Right? Then what happened was there. So again, you are going to plot up these things like this. No, right? අදිනෝ එකේදී 40යි 20යි පේන්න ඕනේ. ඊට පස්සේ දෙකේදී 50යි 30යි පේන්න ඕනේ. තුනේදී 70යි 60යි පේන්න ඕනේ. හතරේදී 15යි 28 පේන්න ඕනේ. පහේදී 30යි 40යි පේන්න ඕනේ. මෙන්න මේ විදිහට අපි හිතනවා. data points ටික විහිදලා තියෙන්නේ මෙහෙම කියලා. Then what you are going to do now? Actually, you can decide, right? You can decide how many components, principal components do you want? How many principal components do you want? That is the first thing you need to decide. Then assume you should need to have only one principal component. You can draw a line like this. This is we are calling principal component number 1. Right? අපි මෙහෙම හදලා ඉවරලා අපි මොකද්ද කරන්නේ? First you need to decide what is the central point. Yes, you need to decide the central point. This is the central point. Then අපි මොකද්ද කරන්නේ? Yes, what is the thing you are going to do? අපි මේ හැම data point එකේ ඉඳලම මේ central point එකට කොච්චර දුරක් තියෙනවද කියලා අපි බලනවා. Right? මේ හැම data point එකක ඉඳලම right? මේ හැම data point එකකම ඉඳලම කොච්චර දුරක් මේ central point එකට තියෙනවද කියලා බලන්න. අපි ඒක කොහොමද බලන්නේ? First you need to draw a tangent line to this line. I will use another color. හැම point එකේ ඉඳලම මේ line එක අපි නිල් පාටින් line එකක් හදන්න PC1 කියලා. PC1 වලට ලම්බකව ඉරක් අඳිනවා. මෙන්න මෙහෙම. Right. Then this point to this point you are going to take the distance D1. Here to here D2. Here to here D3. Here to here D4. Just for understanding purpose only. You don't want to calculate it. System will automatically generate whatever the information, right? So for the time being, I'm saying yes. If what you need to do is first you need to identify the central point, then you need to draw the PC1 line and get the tangent lines to that CP line and get the distance. මොකද්ද කරේ? Central point එක හොයාගත්තා. මේ තියෙන central point එක. ඊට පස්සේ නිල් පාටින් line එක දාගත්තා. That is the CP1. Then your data point එකේ ඉඳලා මේ central point එකට කොච්චර දුරක් තියෙනවද කියලා බලන්න. අරගෙන අපි ඒ එන value එකේ square value එක ගන්නවා. ඒ square value එකක් ගන්නෙ. What is the reason for getting the square value? ළමයි මේ බලන්නකෝ. මේ පැත්තේ ඉඳලා මේ පැත්තට තියෙන difference එක ගත්තොත් ධන difference එකක් තියෙන්නේ. හැබැයි මේ central point එකේ ඉඳලා අනිත් පැත්තට ගියොත් if you are going for the left side, so you are making a negative difference. අපි difference එක ගන්න කොහොමද? පසු පදයෙන් පෙර පදේ. past term එකෙන් first term එක අඩු කරනවා. එතකොට වැඩි අගයකින් අඩු අගයක් අඩු කරොත් ප්‍රශ්නයක් නෑ ධන අගයක් එන්නේ. හැබැයි අඩු අගයකින් වැඩි අගයක් අඩු කරොත් ඔයාට එන්නේ අඩු අගයක්. So that is making a negative impact. So මේ ධන ඍණ කියන සම්බන්ධය නැති කරන්න ඕනේ හින්දා. ඇයි ධන වලට සමානව ඍණ සංඛ්‍යාවක් ආවොත් ඔයාගේ වෙයි මේ ඩිෆරන්ස් එක 0 කියලා. එතකොට අපිට මේ ගාන හදන්න බෑ. So you need to take the difference and then you need to get the square value of that. එතකොට අපි මොකද කරන්න ඕනේ? අපි ගාව තියෙනවා D1, D2, D3 and D4 and D5. So I'm getting the square value of this. Getting these 5 square values, you need to calculate the sum of the square distance for the PC1. මේ square value වල එකතුව ගන්න ඕනේ. එකතුව ගන්න ඕනේ. That's the sum. That is the first thing. Assume if you want to take the principal component, so we can say it as like this, right? So you need to take two principal components. Here you can see only one. So if you want to take another one, what you can do is again you need to draw a line for in this side, right? You need to get the another line for this side. So we are calling it as principal component 2. Again, what you need to do, you need to mark the central point. Based on that, you need to take the distance. You need to take the distance by getting the tangent line for this green color one. එතකොට අපි බලන්න මෙන්න මේ පැත්තේ ඉඳලා කොච්චර දුරක් තියෙනවද? මෙන්න මේ පැත්තේ ඉඳලා කොච්චර දුරක් තියෙනවද? අපි හිතමු මෙන්න මේ හැරි data point එකක් තිබ්බා කියලා. එතකොට මෙතන ඉඳන් මෙතෙන්ට ගහලා මේ central point එකට කොච්චර දුරක් තියෙනවද? Likewise, then you can have the distance in relevant to the PC2. So I am taking the next letter as K, right? K1 plus K2 plus K3 plus K4 plus K5. Again, square root values you need to take and you need to get this up. අපි හිතමු මේ විදියට අපි central point එක කරහා යන lines ඕන තරම් දාලා PC1, PC2, PC3, PC4 කියලා ගත්තා කියලා. So the argument or my point is how you can decide what would be the principal component. Actually you need to eliminate මේ principal component වලින් කොහොමද අයින් කරන්න කියලා අපි තීරණය කරන්නේ කොහොමද? එතනදී we are getting the decision according to the rule. Rule is what? Less amount of sum of squared distance value PC going to be cancelled. මේ කියන දෙකට comparatively අඩුම square value එක sum of square value එක අඩුවෙන් එන component එක තමයි අපි ඉක්මනටම අයින් කරලා දාන්නේ. වැඩියෙන් තියෙනවා කියලා කියන්නේ මේකට වැඩි බලපෑමක් ඇති කරනවා කියන එක. Clear? If you get the lower sum squared values relevant to the PC, so that PC value you are going to eliminate from your decision. So actually that is the thing you are going to do. Actually that is the thing you are going to do. So actually I need to share a video with you, right? So please give me 1 second. Feature extraction and selection. We'll see. Is it work? Yes, it's work. Please look this video, then you can understand what we discuss, right? Is it visible? Yes or no? So I got the message. Yes, okay.
Hello, welcome to dimensionality reduction using feature extraction and feature selection. Dimensionality reduction is the process of reducing the number of variables or features in review. Dimensionality reduction can be divided into two subcategories called feature selection, which includes wrappers, filters, and embedded, and feature extraction, which includes principal components analysis. So how exactly does dimensionality reduction improve performance? It does so by reducing the number of features that are to be considered. To see how this works, think of a simple algebraic equation. A plus B plus C plus D equals E. If you can equate AB equals A plus B, making a representation of two variables into one, then you're using feature extraction to reduce the number of variables. Now, consider if C was equal to 0, or an arbitrarily small number. It wouldn't really be relevant, therefore it could be taken out of the equation. By doing so, you'd be using feature selection, because you'd be selecting only the relevant variables and leaving out the irrelevant ones. Feature selection is the process of selecting a subset of relevant features or variables. There are three main subset types: wrappers, filters, and embedded. To help you visualize how feature selection works, imagine a set of variables. Let's use a series of shapes, for example, with each shape representing different dimensions or features. By ignoring the irrelevant variables, or selecting the ones that improve accuracy, we reduce the amount of strain on the system and produce better results. Wrappers use a predictive model that scores feature subsets based on the error rate of the model. While they're computationally intensive, they usually produce the best selection of features. A popular technique is called stepwise regression. It's an algorithm that adds the best feature or deletes the worst feature at each iteration. Filters use a proxy measure which is less computationally intensive but slightly less accurate. So it might have a good prediction, but it still may not be the best. Filters do capture the practicality of the dataset, but in comparison to error measurement, the feature set that's selected will be more general than if a wrapper was used. An interesting fact about filters is that they produce a feature set that don't contain assumptions based on the predictive model, making it a useful tool for exposing relationships between features, such as which variables are bad together and as a result drop the accuracy, or good together and therefore raise the accuracy. Embedded algorithms learn about which features best contribute to an accurate model during the model building process. The most common type is called a regularization model. In our shape example, it would be similar to picking the shapes or good features in each step of the model building process. It might be picking the triangle feature in step 1, picking the cross feature in step 2, or picking the lightning feature in step 3 to obtain our accurate model. Feature extraction is the process of transforming or projecting a space composing of many dimensions into a space of fewer dimensions. This is similar to representing data in multiple dimensions to ones that are less. This is useful for when you need to keep your information, but want to reduce the resources that it may consume during processing. The main linear technique is called principal components analysis. There are other linear and nonlinear techniques, but reviewing them here is out of scope for this course. Principal components analysis is the reduction of higher vector spaces to lower orders through projection. It can be used to visualize the dataset through compact representation and compression of dimensions. An easy representation of this would be the projection of a three-dimensional plane to a two-dimensional one. A plane is first found which captures most, if not all, of the information. Then the data is projected onto new axes and a reduction in dimensions occurs. When the projection of components happens, new axes are created to describe the relationship. This is called the principal axes, and the new data is called principal components. This becomes a more compact visualization for the data and thus is easier to work with. Thanks for watching.
Okay, students, please give me 1 second, right? In your practical notes, students, you can read this entire paragraph, and then you can identify, then you can understand what we discussed up to now. And here you can see PC1, PC2, PC3, likewise. It's showing the principal component, number of principal component. They are saying, then the brain data set, column number 2 to 7, you can take the principal components, right? 2 to 7 means principal component 1, 2, 3, 4, 5, 6. They identify 6 principal components, right? Well, here you can see, if you are taking only the principal component number 1, yes, what is the value here? If you are taking components 2 components, what is the value? If you are taking 3 components, what's the value? If you are going to increase the number of components, now you can see what happened. It's showing the value goes down. Values goes down, right? Yes, then it will recommend to take only 1, 2, 3, 4. Yeah. The principal component 1, the calculation also there, right? So everything you can get automatically from the system. So I'm showing how to interpret and all for in next day. So so what you need to understand is what the thing we discuss here, the everything so you can use for your day-to-day activities. So if you are going to not use 6 component rather than 6, if you are going to use 4, yes, what happened? So it is also showing, right? So likewise, based on the outcomes or the based on the output, yes, you can decide what would be the best number of principal components that you can use. So everything we can discuss in next discussion at the computer